Hello everyone. Topic 2 is transformations of quadratic functions. So how quadratic functions move around based off of the parent function x squared. So the word transformation just means that, how they move. Find the vertex, so objective 1 in this video, and I'm going to do objective 1 and objective 2 within this video. Alright, so objective 1 is just finding the vertex and describing the transformation taking place based off the parent function x squared. Alright, so there's no drawing in this objective yet. We're going to come back and draw them after we learn objective 2. So both are pretty quick and both are pretty straightforward. That's why I'm including them both in this video. But again, objective 1 is the first knowledge you need that builds upon to objective 2, and then objective 2 is going to come and finalize this whole process for topic 2. Alright, so to begin objective 1, we need to look at the parent function, because it says everything is based off the parent function of x squared when these quadratic functions are moving around. So the whole goal of this process is to find the vertex. And when you find the vertex of the given function, you can describe the transformation taking place based off of the parent function, x squared, its vertex. And so I'm going to first find the vertex of x squared, just to show you that it exists where it does. If you notice, this is a function. It doesn't have, because the original function is a times x minus h squared plus k. That's vertex form right here. It does not have an a. Technically it's 1 that it exists. Just crossed out the x. Technically it's 1. It exists in front, but we don't have to write it if it's 1. It doesn't have an h value or a k value. That means it's not that they don't exist. It just means that there's no movement that's happening. So the h value and the k value for the parent function of x squared is 0, 0. So the x and y value of the vertex are 0, 0. So that is my vertex, 0, 0. So I'm going to base everything I do within these objectives off the parent function vertex of 0, 0. Now, let me show you this process then, at least for objective 1. To master objective 1, this is what you're going to have to do. If I was going to give, or if I was given number 2 as an example, y equals x minus 2 squared plus 4, I would need to first identify the vertex. Alright, and I should be thinking to myself, what form is this? Is this vertex form? Or is this standard form? And it looks to be vertex form. It has an h value and it has a k value. Same as up here. So it is vertex form. And if you remember from previous videos, the only thing tricky about this is knowing that the h value to the left is lying to you. So it's x minus 2 within the function. It's positive 2 in the actual coordinate point of the vertex. So the x value is 2, the y value, remember this is h and k, or x and y. The y value is 4. That is my vertex. So I go over to 2, up to 4. And then to describe the transformation taking place based off the vertex, I'm just going to write this function shifted right 2 spaces and up 4 spaces. Please write in complete sentences. If you don't, it will be counted a little bit incorrectly on the test. So this function shifted right 2 spaces and up 4 spaces. That satisfies the movement of the vertex. Because the vertex moved over 2, up 4, that means every point within this given function moved over 2, up 4. And so I have just satisfied objective 1. I have stated the transformation that existed. Objective 2, we're going to learn how to draw, how to draw the actual graphs themselves. So please pause the video at this time and try to find the vertex of this number 4 example, and then state the transformation that happens. So please pause the video. You should have paused the video and tried number 4 on your own. I have found the vertex based off the function itself. This is the h value and the k value, or the x and y value. But remember, the h value is always lying to you. So it's x plus 4 in the function, meaning in the actual coordinate point of the vertex, it has to be -4. It's line Q, it's opposite or whatever it is. And the K value is telling the truth. And H and K is X and Y, so then I plot it, I go over to -4, left -4, down to -2, that's this dot here. And then I wrote it out in a complete sentence. This function shifted left 4 spaces and down 2 spaces. If your work matches my work on the screen, then you have mastered Objective 1 for this process. Now let's move on to Objective 2. In Objective 2, now we're given the same 3 functions, all right? And then we're going to practice this a little bit further in depth. But Objective 2 says to draw the graph of the new function using the step pattern. And it says keep in mind the A term multiplier, and I'll talk a little bit about what that is, all right? What I said in these steps over here in red, this is the step pattern it's considered if the A term equals 1. So anytime the A term equals 1, this is the pattern you're going to use. If you notice, all of these A terms equal 1. All right? So this is how we're going to draw these exactly. So I said before, earlier in this video, this vertex is 0, 0. This is the parent function x squared. So I plot it here. The step pattern for if A equals 1 is going to be over 1, up 1, over 1, up 3, over 1, up 5. All right? So I'm going to go. And this happens because these are symmetrical, they have an axis of symmetry, it happens on the left-hand side and the right-hand side. So I'm going to go over 1 on the right, up 1, right there. I'm going to go over 1 on the right, up 1, 2, 3, right there. And over 1 on the right and up 1, 2, 3, 4, 5, right there. And then over 1 on the left, up 1, over 1 on the left, up 3, over 1 on the left, up 5. To check your work, it should be identical on both sides with the axis of symmetry at x equals 0. So that is a better, more accurate sketch of my parabola. Now let's talk really quick what's actually happening. In the function x squared, if I input, let's say 1 into the function, I get 1 for my y value. So this point right here is 1, 1. Let's input 2 into the function. 2 squared, if you look right here, is 4. So that's this dot right here. And then let's input 3 into the function. 3 squared, this dot right here, is 9. So that is where the step pattern is born from, that process of, it's just based off of the first 3 squarings of the numbers, or first 3 perfect squares. And if you notice in the negative direction, -1 squared is 1, -2 squared is 4, and -3 squared is 9. So it works in both directions. So that's where the step pattern comes from. So this step pattern, again, if A equals 1, will work no matter where the vertex is. So that's where this process, and I'm going to show you this example. So again, we're describing the transformation based off the parent function that I just graphed. And we found this vertex to be 2, 4. All right, so I'll plot 2 up to 4 right here. And this step pattern works no matter what. The A, we already identified, A equals 1 here. So I can use this version of the step pattern. So I go over 1, up 1. Over 1, up 3, 1, 2, 3. And over 1, up 1, 2, 3, 4, 5. At times, you might have to estimate where it is on the graph like I just did. That's totally fine. All right? So now I go over 1, up 1. Over 1, up 1, 2, 3. And over 1, up 1, 2, 3, 4, 5. So this is a much better drawn graph of this given function in vertex form. If you notice now, because we drew it perfectly and accurately, we do have a graph feature. We have a y-intercept. We have discovered that the y-intercept is 0, 8. Because we were able to graph it and graph it correctly, it gave us a perfect image of where the y-intercept is. And so now I have mastered Objective 2. I have used the step pattern if A equals 1 to draw my graph based off of the pattern that exists. Up, over 1, up 1, over 1, up 3, over 1, up 5. Now, pause the video and try number 4 on your own. Identify the vertex and use that step pattern to draw the parabola. At this point, you should have paused the video and identified the vertex, which you did in objective 1, as -4, -2. So I plotted that, and then I used the step pattern of over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 1, over 1, up 3, over 1, up 5. Now, if you notice, this process didn't necessarily give me the y-intercept, all right? So at times it will give me the y-intercept, at times it won't. I will say, though, on the test, you will be given functions that will give you the y-intercepts and the x-intercepts very nicely so that you can see them, all right? So at this point, if your graph looks like mine, you have mastered objective 2 if the a value is 1. Now, one more thing, though. The second part of objective 2 is what happens if the step pattern isn't 1. That's what this means. A does not equal 1. So if you notice in this example, my a value is 2. So what's actually happening? Again, I'm inputting x values into a function and they're outputting an output. But this a term is a multiplier, so it's going to be multiplying my output by 2 every time. So it's going to be changing my y value by a factor of 2 every time. So if I do the original step pattern, over 1, up 1, over 1, up 3, over 1, up 5, what's happening is the up 1, up 3, up 5 are talking about the y value. So this is all going to be multiplied by 2, 2, and 2. So now it becomes over 1 up 2, over 1 up 3 times 2 is 6, over 1 up 5 times 2 is 10. Alright? So it's the same process. I plot the vertex, which in this case the vertex is 1, -4. So 1, -4. But instead I'm going to go over 1 up 2, over 1 up 1, 2, 3, 4, 5, 6, over 1 up 10, over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, somewhere up there. Same thing, over 1 up 2, over 1 up 6, over 1 up 10. There is my parabola. If you notice, based off of parabolas where the a term, the a multiplier is 1, so over here it's 1, this one has gotten vertically skinnier, so it's stretched vertically by a factor of 2. So anytime that the a is not 1, it will be stretched vertically by whatever that factor is. So if a is 3, it will be stretched vertically by a factor of 3. Now, I'm going to have you try number 3 on your own. If you notice, though, a is -2. So hopefully you can use our new step pattern, over 1 up 2, over 1 up 6, over 1 up 10. But what happens, remember, what does the negative do to the function? Positive functions open up, negative functions open down. So please consider that when you're trying to draw this. Please pause it and give this one a shot. This time you should have paused the video and tried this one on your own. I found the vertex to be -3, -4, and that's where I plotted it right here. And hopefully you saw that this -2 sends the graph downward. It's going to open downward because negative forms frowny faces. So instead of going over 1 up 2, over 1 up 6, over 1 up 10, I went over 1 down 2, over 1 down 6, over 1 down 10. If you have a question on that, please raise your hand, but otherwise, if your work looks like mine, you're free to move on to the practice.